Hi kids, and welcome back to Common Core Algebra II. Today's lesson is 5.2, Arithmetic and Geometric Sequences. Now back in Algebra 1, we talked about these, so these should not be new to you. We're going to talk about them in direct formula or explicit formulas and in recursive definitions. An arithmetic formula is based on a constant addition to get to the next term. Now don't get confused with that word addition either, because it could be the addition of a negative number, and we refer to that as the common difference. We also refer to a geometric sequence as a number being multiplied by the next term, by the previous term, to get to the next term, and we call that the common ratio. So if you take a look right down at the bottom here in the box, we have arithmetic sequences in the recursive definition where once again you have to be given that first term. So f of 1 needs to be equal to something, and the term we're looking for is equal to the term prior to that plus that common difference that we were just talking about. And if it's an increasing sequence, then it's going to be added, and if it's a decreasing, it's going to be subtracted, or a positive number being added or a negative number being added. All right, so we'll take a look at a few of these examples. So in exercise 1, generate the next three terms of the given arithmetic sequences. So f of n equals f of n minus 1 plus 6. So it's really important to make sure that we're making sense of this. So this right here, this is the term we're looking for. And this right here is the previous term. So don't get confused about that n minus 1. All right? So in this case, we know that f of 1 is equal to 2. They have to give us that, which they did right here. Now to find f of 2, this is the term we're looking for. It's going to be, now if we do it according to our definition, we know here n is equal to 2. So f of 2 minus 1 plus 6. So this becomes f of 1 plus 6, and we know f of 1 is 2 plus 6 is equal to 8. Now that's kind of the long way around it, but I want you to make sense of it before we start kind of taking shortcuts here. So to find f of 3, it's simply going to be, now you can go through that whole process we just did, or you can kind of make sense of it and say, well, it's the previous term, which is 8 plus 6. So my third term is going to be 14. And then f of 4, because it says find the next three terms, would be the previous term plus 6, which would be 20. So take a minute and make sense of that. And let's move on to B. Now again, this is the same thing, except it's different notation. So don't get yourself caught up in the notation. The first one was using, in A, we use a function notation, and in B, we're using really a sequence notation. So on this one, again, let's try to make sense of it. This is the term I'm looking for. This is my previous term. All right, plus 1/2, and then they tell us what our first term is. So a sub 1 is equal to 3 over 2. So a sub 2, the term I'm looking for, is equal to the previous term plus 1/2. So this is going to equal 4/2, which is equal to 2. A sub 3 is equal to the previous term plus 1/2, which is equal to 5/2. Or you could write 2.5, but again, those mixed numbers, they're having an identity crisis. I prefer not to use them. So remember, when you're doing this, you can do it in your calculator, or you can convert your 2 to 4 divided by 2, because that's the same thing as 2. So 4/2 plus 1/2 is equal to 5/2. Let's take that out so I don't confuse you. All right, so now we need one more. We need a sub 4 is equal to the previous term plus 1/2. All right, remember how to add fractions, by the way. We keep the denominator, we add the numerators, which is 6 over 2, which is equal to 3. So pause when you need to, write down what you need to before we move on to exercise number 2. For some number t, the first three terms of the arithmetic sequence is, are, we have 2t, we have 5t minus 1, and 6t plus 2. So what is the numerical value? So what is the numerical value of the fourth term? And here I give you a little hint. First, set up an equation that will solve for t. So this gets a little confusing, but the first thing I always like to start with is to write down my terms. Again, I make my t's a little curved so that way I don't get them confused with plus signs. So, So I know that this is going to be an arithmetic sequence. So that means I know I have to have a common difference. So that means I know that if I start with 2t, I have to add something in order to get to the next term, which is 5t minus 1. So what exactly do I have to add? In order to get to 5t minus 1, I have to add a 3t, right? 2t plus 3t is 5t. And then I also have to add a minus 1 because I have a minus 1 on the right-hand side. All right, are you with me? And similarly, we have to do the same thing for the next two. I know if I start with the second term, 5t minus 1 plus that common difference again, and remember, they're the same common difference, 6t plus 2. So now I have to say, well, to get from 5t to 6t, I have to add 1t. And to get from a negative 1 to a positive 2, I have to add 3. Right? That makes sense? 5t plus t is 6t, and negative 1 plus 3 is positive 2. All right, well, that was kind of a little common sense. But I know that this common difference, these boxes, have to be the same. So I know that 3t minus 1 has to equal t plus 3. I'm going to bring this t over. And I have 2t minus 1 is equal to 3. Add 1 to both sides. 2t is equal to 4. And t has to equal 2. All right, so now I have to go back and actually find the common difference now, though. So t is equal to 2 is not my common difference. My common difference goes back to my 3t minus 1 and my t plus 3. So 2 plus 3 is 5. So this box is 5. And this is 3. I'm looking right here. 3 times 2 is 6, and 6 minus 1 is 5. So I know my common difference has to be 5. All right, so, you could come back here and put your t's in, because I know this is going to be 2 times 2, which is 4. I know this is going to be 5 times 2 minus 1, which is equal to, 10 minus 1 is 9. And this is going to be 6 times 2 is 12. 6 times 2 is 12, plus 2 is 14. All right, so now if you look, I did add 5 each time, and they're asking us for the fourth term. This is the first term, the second term, the third term, and the fourth term would be the previous term plus 5, which would be 19. Okay, that was a little bit tricky, but you know, this is not difficult. Remember our mathematical practice number 1 says make sense of problems and persevere in solving them. So please think about that you do have the knowledge to do these problems. So don't quit so quickly. All right? I bet you if you just spent a little time thinking about it, you would get these without my help. All right? So pause, write down what you need to, really take a minute and think about this before we move on to exercise number 3. Okay, it is important to be able to determine a general term of an arithmetic sequence based on the value of the index variable, which is the subscript, at that little, sub 2, sub 3. The next exercise walks you through the thinking process involved. So consider a sub n is equal to a sub n minus 1 plus 3, with a sub 1 is equal to 5. Again, before I even move on, I make sense of it. This is the term I'm looking for. This is my previous term, and I'm going to add 3 to that term to get to the term I'm looking for. So they tell me that a sub 1 is equal to 5. So a sub 2 is equal to the previous term. And again, if you want to make more sense of this, you can do it this way. You can say a sub 1, I'm sorry, we're looking for a sub 2 minus 1 plus 3. So what does that mean? That means, this is not very clear to me, so let's take a minute and just see if we can take this out and rewrite it. Okay, in this case, n is equal to 2, and this is going to be 2 minus 1. So a sub 2 minus 1, then we're going to add 3 onto it. Ooh, the board is getting spooky again. So the previous term is a sub 1 plus 3, and a sub 1 is 5 plus 3, which is 8. Okay, so if it makes more sense to you to do that, then feel free to. But once you start getting good at these, you can say to yourself, I'm looking for the third term, which is going to be the previous term, plus 3. So this is going to be 11. And a sub 4 is going to be the previous term, plus 3, which is 14. Again, if you do better with doing it like I found the second term, then feel free to continue doing it that way. B says, how many times was 3 added to 5 in order to produce a sub 4? Well, let's take a look at that. I can't pull the other ones around. Oh well, I guess I have to use this one. All right, so I started with 5. I added once, right to here. I added once. I added twice. I added 3 times. So I added 3 times to 5 to get a sub 4. So use your result from part B to quickly find the value of a sub 50. So I think what they're saying is that to get to a sub 4, we had to add 3 times, which means that we did 3 times 3 is 9, and then we added that to the 5. So keeping that same thought, in order to get to a sub 50, all right, we're going to have to take 5, and what are we going to have to do to it? We're going to have to multiply 3 times what? 49? Right? And then what do we have to do? We have to make sure we add that original 5 on here. So we get 147 plus 5, which is 152. And D says, write a formula for the nth term of the arithmetic sequence a sub n. So I think what we can do is here and say a sub n is equal to, remember what 3 was, that was our common difference. So let's call it D, all right? D times, and then this number here was n minus 1, but then you have to remember to add that first term back together. So this is a beautiful thing to be able to use, but you kind of have to know that. So it's the common difference times n minus 1 plus a sub 1. And so just for a quick example, we found the 50th term over here on the left on C. What if you wanted to find the 100th term? If you wanted to find the 100th term, you would say the common difference is 3 times 99 plus 5. Okay? So that's just a way to do it. I'm not even going to do the math here. If you wanted to find the 1000th term, the 1000th term would be 3 times 999 plus 5. Okay? So that formula that we just found, we're going to be able to use that in future examples. All right? So write down what you need to, and let's move on to exercise 4. Given that a sub 1 is 6 and a sub 4 is 18 are members of an arithmetic sequence, and that's very important. They have to tell you that because otherwise you don't know what kind of sequence it is. Determine the value of a sub 20. So we have a sub 1 and a sub 4, and we need a sub 20. So there's two ways that you can do this. One way is you could just write out all 20 terms. But if you're asking, like on the example we just showed, if you needed the 1,000th term, to spend 3 hours on a Regents exam determining what the first 1,000 terms are would really not be beneficial. But the first thing we need to do is determine what that common difference is, because we have the a sub 1, we need the common difference, and that's not given to us. So I know that the first term is 6. I know that the second, third, and I know the fourth term is 18. So what I need to know, how can we find the second and third term? Well, I know that from here to here is 18 minus 6, which is 12, right? So now if you consider 12, now I have to break that up into 1, 2, 3. So if I'm going to break 12 up, what do I have to add each time? I add 4, 4, and 4. Do I get the same? So 6 plus 4 would be 10. 10 plus 4 would be 14, and 14 plus 4 is 18. So there we go. So we know our common difference is positive 4. So now in this case, we can go and use our formula. We know that our formula is going to be a sub n is equal to d times n minus 1 plus a sub 1. So we're looking for the 20th term is equal to our common difference, which is 4, 19 minus 1, and add back our first term, which is 6. So once you do the math here, you come out with 82. Now there is another way that you can approach an arithmetic sequence, because an arithmetic sequence is basically a linear function. So what you can do is you can determine what the slope is, because obviously if your common difference is g, that's also going to be your slope. M is 4. And the only other thing that you need, remember you have y equals mx plus b. So you need your y-intercept. All right. Now, remember when we looked at that one example where we looked at the numbers of an arithmetic sequence, they did form a line. But one thing that we never did consider is when it touches the y-axis, because obviously you can't have a zero term. But in order to have that equation, you kind of have to consider that zeroth term. So what you can do is kind of over here on the sneak, you can figure out what your zero term is. And your zero term would be, instead of adding 4, you would minus 4. So your zero term would be 2. So the equation of my line would be y is equal to 4x plus 2. And now if you're looking for the 20th term, you'd say y is equal to 4 times 20 plus 2, which also gives you 82. Remember, I always like to give you more than one option to find things, because if by chance the time comes that you forget this, all right, then this is another way you can go back to that, remembering what you know about linear functions, because you could graph this. This would be 1 comma 6. This would be, I'm sorry, I'm saying this, you know what I'm talking about. This could be 1 comma 6. This could be 2 comma 10. This could be 3 comma 14. I'm sorry, I did that wrong. And this could be 4 comma 18. So these are points and they form a line. So you can very easily put them on a piece of graph paper, determine where the y-intercept is, use your common difference of 4, and still figure out at the 20th term, so when x is equal to 20, what happens to my my y? And that's what we're looking for. So you could use a piece of graph paper to solve this as well. Okay, moving on. We still have 2 more to do, but we're going to start talking about geometric sequences. All right, so here we have the same situation because a geometric sequence is also going to use a recursive definition. We're going to be given f of 1. All right, f of 1 is equal to this. Then the term I'm looking for is equal to the previous term. That's what this is. The previous term times r, which we call the common ratio. All right. So again, this is the other way to do it. This is using the recursive. All right, so a sub 1 is equal to, a sub 1 is equal to something. A sub n is equal to a sub n minus 1 times r. So the term I'm looking for is equal to the previous term times r, where r is called the common ratio, and it can be positive, negative, and is often fractional. So exercise 5 says generate the next 3 terms of the geometric sequences below. So let's take a look at these. So we know that a sub 1 is equal to 4. So in this first example, they're just telling you the common ratio is 2. So I know that the second term has to be the previous term times 2, which is 8. The third term is the previous term times 2, which is 16. And the next 3 terms, I need one more. So a sub 4 is equal to the previous term times 2, which is 32. So my sequence is 4, 8, 16, 32, and so on. Taking a look at B, again, making sense of it, f of n. So f of n is the term I'm looking for. F of n minus 1 is my previous term times 1/3. So we're given f of 1 is 9. So f of 2 is going to be my previous term times 1/3, which is 3. My third term is going to be my previous term times 1/3, which is 1. And my fourth term is equal to the previous term times 1/3, which is 1/3. All right, taking a look at C, make sense of what this says first before you try to jump into it. This is the term I'm looking for. This is my previous term. If you need to write terms, write little notes, that's fine. Remember, mark up your paper. It helps you. So this is the term I'm looking for. All right, that's my previous term times rad 2. So I know my first term is 3 rad 2. My second term is equal to, now don't get flipped out by the radicals. You can use your calculator if you need to. So this becomes my previous term times rad 2. Okay, so rad 2 times rad 2 is 2, and 3 times 2 is 6. The third term is my previous term times rad 2, which is 6 rad 2. And my fourth term is equal to my previous term times rad 2, which is 6 times 2, which is equal to 12. Okay, write down what you need to. We have one more question to consider, and then you're done for the day. So we're going to kind of do the same thing that we just did. We're going to walk through what we did with geometric sequences. So here we're given a geometric sequence that says a sub 1 equals 2, which means our first term is 2, and the term we're looking for is equal to the previous term times 3. So in this case, our common ratio, or our r, is equal to 3. So generate the value of a sub 4. Well, that's easy enough to just write them down, because a sub 1 is 2. A sub 2 is the previous term times 3, which is 6. A sub 3 is the previous term times 3, which is 18. and a sub 4 is equal to the previous term times 3, which is 54. So that's easy enough. There's your answer. B says, how many times did you need to multiply 2 by 3 in order to get a sub 4? So how many times did we have to do? We have to start with 2, multiply by 3 once, multiply by 3 twice, multiply by 3 3 times. So again, you're using that same n minus 1 here. So that's kind of important. But we just have to set it up a little bit differently, because when we determine the value, again, we're going to use a sub 10, all right, not a number that's kind of far away from what we need to. But a sub 10, this is something you would be able to spend some time and do it out. Okay, so a sub 10. So we're going to assume this like a sub, 300. So that way, we'd have to use a formula. So a sub 10 would equal 2 times our common ratio raised to the 9th power, because it's n minus 1. So this turns out to be, kind of a big number, 39,366. I can do that in my head. No, I really can't. Okay, so D says write a formula for the nth term. So it's the same situation as we had for our arithmetic. So we have a sub n is equal to a sub 1, which was our 2, times, now be careful here, what did we do? We did times our common ratio to the n minus 1. So we're going to be able to use this one now to solve for some other larger terms of our geometric sequences. All right, so really kind of make that one a priority, put a nice big box around it, and the previous one that we did with our arithmetic sequences, which is really important as well. Okay, so tomorrow in class, or Monday, or whenever this happens to be watched, we are going to be working on the classwork for this. So make sure you bring it in so I can give you credit for watching your notes. And until then, make good choices. Bye.